Hello everyone, myself Sai Prasad, Alexian, Ahilabad High School and the Junior College. Welcome to the series of the lectures of Intermediate First Year Maths P. We have started our discussion with the chapter Applications of Derivatives. What did we learn? We started with errors and approximations, tangents and normals, right, and all those chapters. Now we are going to start a new topic, that is maxima and minima. This is very important, and the only thing is you have to remember the steps how to do, and one more thing is this will be a last topic of your chapter. Okay, see here, when a function is said to have a maximum function, maximum value. For example, let me tell you, there is a function f of x. Okay, we know that this is continuous within a particular range, let us assume. Okay, then at what value this function will have maximum number? Let us say it has some sine function like this. Okay, then it ranges from 0 to pi, let us say. Then at what point the sin x will have maximum value? Yes, that is at pi by 2, which is 1. How to identify it? How to prove it? That is what we are going to learn in this point. Clear? Let me tell you again. If there is a function f of x which is continuous within a particular range, then how do we confirm that it has a maximum or minimum value? First thing. Second, if it has a maximum value, then you have to tell at what point it has maximum value. Okay, or else vice versa. If it has a minimum value, then at what point it has that minimum value. Can we? Yeah, that's what we are going to learn. How do we prove is, first whatever it is, he gives f of x. Okay, then next we have to differentiate, single differentiation, equate it to 0, you will get some value of x. Yes, fine. Then next, double derivative it. Okay, now substitute this value here. Okay, then check whether this value is greater than 0 or less than 0. Okay, if it is greater than 0, then the function f will have minimum value. Okay, and if this f double dash x is less than 0, obviously it will have maximum value. Okay, and at what point it will have maximum value bole to, it will have maximum value at this point. Okay, from this point we will get some value of x, right? We will get some value of x, we will substitute it here. Whatever the point we got here, that will be my maximum or minimum value. At that point we will have maximum or minimum value. Okay, is it clear? Fine. Shall we do few problems? Okay, the only thing we have to remember is, we have to take the function, then differentiate it, equate it to 0, find the value of x, again differentiate it, substitute in this, check whether it is greater than or less than 0. Fine. Shall we start doing problems? Let's do. Look at the given questions here. He gave, find two positive integers x and y such that these are the two relations given and it has the maximum value at sums. Okay, at what point we have to we have to find x and y of these functions where it is maximum. Okay, let us combine both the equations first. Okay, x plus y equals 60, then can I write y as 60 minus x? Yes, so from that I can write xy cube as x into 60 minus x whole cube, isn't it? Let us take this as my function, f of x is equal to x into 60 minus x whole cube. Yes, what will be my first step now? I have to differentiate this term with respect to x. First derivative, differentiate with respect to x. Then f dash of x is equal to uv rule. Fine. X, let us put it like that, and here 360 minus x whole square into minus 1 plus 60 minus x whole cube. Yes, this is my f dash of x. Check again, u v dash plus v u dash. X ka differentiation is 1. Now let us equate it to 0. Okay. Can I take 60 minus x whole square as common? 60 minus x whole square, if I take it as common, I will be left with minus 3x plus 60 minus x. Okay, here minus 3x and here 160 minus x is left. So this will become as 60 minus x whole square into 60 minus 4x. So let me take all equal to 0, that is 60 minus x is equal to 0, 60 minus 4x is equal to 0. Then what do we get? 60 is equal to x and here 60 equal to 4x. Here x equal to 60. Can I cancel this? 4 ones are 4 15s are. Isn't it? I got two values of x. One is 60 and one more is 15. Now let us find the double differentiation of this function. Let us directly take this term. Okay. U v term. Okay. Now see here 60 minus x whole square, let us put it like that, into 60 minus 4x ka differentiation, that is minus 4, isn't it? Now we will put 60 minus 4x as it is, then I will be left with this term 2 into this minus 1. Fine, that will be 2 into 60 minus x into minus 1. Let me put minus here. Is it clear? Now can I take 60 minus x common? Let us take and substitute it, or else let us directly substitute 15 here. F double dash of 15 is equal to 60 minus 15 whole square into minus 4 minus 60 minus 15 fours are 60 into 2 into 60 minus 60. However, these both terms will get 0. Minus 4 into 16 minus 15 is 45. 45 square minus 4 into, what is 45 square? Tell me. 2025, that is equal to minus 8100, which is less than 0, isn't it? Therefore f is maximum at x equal to 15. Okay. Then if I substitute x in some parameter, I will get y as 60 minus 15, therefore y will be 45 and x will be 15. Clear? Yes or no? These are the basic things which we have to remember. If you want to substitute 60 also here, it will be fine. If you substitute 60 here, there is a problem. 60 minus 60, 0. Again 60 minus this is 15, right? Again here 60 minus 60, both the terms will be 0. Therefore f double dash x is 0. We can't define whether it is increasing, whether it is a maximum function or a minimum function. Clear? Shall we move on to the next problem? Let's do. Look at the question here. He gave from a rectangular sheet of dimension 30 by 80 centimeter. Okay. If there is some rectangular sheet which is 30 centimeter by 80 centimeter. 4 equal sides, 4 equal squares of side x centimeters are removed at the corners. That is like this. They are removed, each of side x centimeters. Fine. Then and the sides are then turned up so as to form a open rectangular box. Just we will tear from this side and they will just turn like this, so as we will get a square, we will get a rectangular box for which the top is open. Then find the value of x so that the volume of box is greatest. Fine. Now just tell me, this is 8, this total is 80 from here to here. Okay. Then what about this distance? 1x is removed, 1x is removed. This will be 80 minus 2x, isn't it? Similarly for this total is 30 from here to here. What if this x and this x are removed? This will be 30 minus 2x. Okay. Now we have to play with that volume. Now just write what are given. Now the length is equal to 80 minus 2x breadth is equal to 30 minus 2x. Now just tell me what is height. Height will be whatever the paper which we have turned up, that is nothing but this part. What is this? X will be the height, isn't it? Fine. Now tell me what is volume? LBH. Yes or no? Fine, very good. That is 80 minus 2x into 30 minus 2x into x. That will be my volume. Yes, then he is asking us to find the value of x so that volume of box is greatest. Greatest is, we have to find the value of x such that this v is a maximum function. Shall we do? See here. That is, what is the first step we have to do? We have to derivate for the first time. Let us multiply before differentiating it. Now see here, 8 3s are 2400, 8 2s are 16, okay, 3 2s are 60, minus to minus plus 4x square. Check again, 8 3s are 24, 8 2s are 16, 2 3s are 6 and 2 2s are 4. This will be 2400 minus 160 plus 60, that is 220x plus 4x square. Now multiply x inside, 4x cube minus 220x square plus 2400x. This is my volume. Yes. Now we have to find dv by dx. Let us do. We have to find dv by dx. That will be 4x cube ka differentiation. 4x cube ka differentiation is 3x square. Therefore, this will be 12x square minus 220 into x square. What it will be? X square ka differentiation is 2x. 2 into 220 is 440x plus 2400 into x, that is nothing but 2400 equal to 0. Yes. Now, can I take anything common from this? We can take 3, right? Yes or no? 3 or 4. Let us take 4 as common. So, I will get it as 4 3s are 12, 11 and here 4 6 are. I will get it as 3x square minus 110x plus 600 equal to 0. From this I can write it as 3x square, 6 3s are 18, 18 ka factors is 9 2s are. So, minus 90 minus 20x plus 600 equal to 0. Let us take 3x common here. I will get it as x minus again 3 3s are. Next there, if I take 20 as common, I will get it as x minus 30. From this I will get x is equal to 30 and x is equal to 20 by 3. I got two values. Now I have to double differentiate it and substitute this value. Now d square v by dx square is equal to double differentiation of this. 12 2s are 24x minus 440. However, that will be 0. Okay. Now we have to substitute x equal 30 and x equal to 20 by 3. For x equal to 30, d square v by dx square is equal to 24 3s are 720 minus 440. Similarly, for x equal to 20 by 3, d square v by dx square is equal to 24 into 20 by 3 minus 440. 3 1s are 3, 8s are. This will be 160 minus 440 and here it is 720 minus 440. How much is it? 440 is 540, 640, 740, 300, this is 280. And what about this? After 160, 260, 360, 460, 300. This is minus 280. Okay. Now if you observe, this has a positive value and this has a negative value. He is telling it should be greatest. Greatest bola to we need a maximum function, which is possible here only for this 20 by 3. I will have a negative function, then only f is maximum. Here v is maximum for x is equal to 20 by 3. Is it? You have to understand the question properly and then only we can solve this kind of problems. Clear? Shall we move on to the next problem? Let's do. See this question. A window is in the shape of rectangle surmounted by a semicircle. Okay, there is some window which is in the shape like a rectangle. Okay, surmounted by a semicircle it seems. If the perimeter of total window is 20 feet, find the maximum area. So, let us assume the dimensions first. Okay, since it is a half circle, let me take the radius of this as x. Then the total diameter will be nothing but the length of our rectangle. Let us say breadth is only y. Is it fine? Now, let me assume that. Let length be 2x, breadth be y. Fine. He is telling that the perimeter is 20 feet. Perimeter is 20 feet. What is the perimeter of this total? 2x plus 2y, yes, plus the perimeter of this circle, I mean semicircle. What is the perimeter of a circle? That is circumference 2 pi r. Here it is only half circle, that is semicircle. This is only pi r. What is r there? X. That will be 2x plus 2y plus half of this, that is half pi x. Okay. Yes or no? There is only pi x, sorry. This is 20. Now put only y this side and send remaining all other things that side. That will be 20 minus 2x minus pi x. That will be, this is 2y. Y is equal to 10 minus x minus half pi x. Is it clear? This is the parameter y. Next, he is asking us to find the maximum area. So, area will be my function. Therefore, area of rectangle, I mean area of this whole window is area of this rectangle plus area of this semicircle. What is area of rectangle? Length into breadth. Length is 2x, breadth is y. Therefore, the area of rectangle is 2xy. Okay. What about this area of semicircle? Half pi r square, half pi x square. Let us substitute the value of y instead of y. Let us substitute this thing. That will be 2x into 10 minus x minus half pi x plus half pi x square. See here, let us multiply 20x minus 2x square minus pi x plus half pi x square. Okay, 2x into half, that will be 2 will get cancelled. I will get it as pi x square, that is equal to 20x minus 2x square, half minus full, that is minus half pi x square. This is my area. Is it clear? Now let us find the minimum or maximum value, that is we have to differentiate it. What do we get? That is dA by dx is equal to, differentiation of 20x is 20, 4x minus half pi into 2x, 2 will get cancelled. I will get it as 20 minus 4x minus pi x. Let us equate it to 0. What do we get? 20 is equal to 4 plus pi into x. Then I will get the value of x as 20 by 4 plus pi. Okay. Now again the next step, differentiate this again, substitute it, you have to get a negative value. What do we get here? D square a by dx square is equal to minus 4 minus pi. Yes, we need not substitute x anywhere here. Obviously this is less than 0. Therefore, a is maximum. Okay, at x is equal to 20 by 4 plus pi. Now we have to substitute this x value and find the area of total thing. What is the area here formula? This is the total area, right? We can directly substitute the value of x here, or else substitute the value of x somewhere here, you will get the value of y. Anything is okay. Let us do this. This is at least better. 10 minus 20 by 4 plus pi minus half pi into 20 plus 4 plus pi. Okay, we can substitute this and simplify. Shall we? See here, LCM is 4 plus pi. Here 40 plus 10 pi minus 20 minus here 2 ones are 2 tens are. I will get it as minus 10 pi. Clear? I have taken 4 plus pi as LCM. Here 40 plus 40 pi, okay, I mean 40 plus 10 pi minus 20 and here minus 10 pi. Clear? If you observe here 10 pi minus 10 pi will get cancelled. I will get it as 20 by 4 plus pi. This is also have the same value of y. Okay. So let us substitute this value of x and y in our area formula. It will be easy. That is, area is equal to 2x y, okay, plus half pi x square. What is x now? 20 by 4 plus pi. Area is equal to, let me take 4 plus pi whole square as LCM. I will get it 2 to the 4, 4 to the 800 plus here 400 by 2, that will be 200 pi. If I want, I can take 200 pi, I mean 200 as common. I will get it as 4 plus pi by 4 plus pi whole square. Therefore, answer is 200 by 4 plus pi square feet. Clear? The sum may be long, but these are the tricks we have to remember. Clear? Shall we move on to the next problem? Let's do. See this question. The question given as, if curved surface of right circular cylinder inscribed in a sphere of radius r is maximum. What did you understand? First thing you have to understand is, leave this. The right circular cylinder, a cylinder, is inscribed in a sphere of radius small r. Yes, remember that. Then the curved surface area of that is maximum. Okay. Then he is asking us to show that the height of a cylinder is root 2 small r. Shall we see here? Let us assume the height, I mean the height of a cylinder be small h. Okay. Height of cylinder is h. Okay. Given the radius of a sphere from here, radius of sphere is small r, already given. Now let us assume the radius of the cylinder. Okay. Radius of cylinder is capital R. So we have to find the surface area. In order to find that, this is right angle, right? From this triangle, let me calculate this capital R. From triangle OAB, I can write it as OA square is equal to OB square plus AB square. Yes. What is OB? What is OA? Small r square is equal to capital R square plus h by 2 whole square. Why h by 2? We have assumed total height as small h. So this will be the half from the center. Is it? Yes. So I can write r square as small r square minus h square by 4. Yes. From this, if we want to simplify, we can write r as under root r square minus h square by 4. Let it be like that. Now let us take CSA of cylinder. What is the formula of CSA of cylinder? 2 pi r h. What is this r? Radius of the cylinder. That is 2 pi. What is r? Tell me. Under root r square minus h square. That is under root r square minus h square by 4 into small h. Clear? Is it okay? Now we have to find the height of a cylinder is root 2r. How do we find? Given that the CSA is maximum. When do we get CSA as maximum? First we have to find f dash, then f double dash less than 0. Okay, shall we do? See here. That is, have to differentiate the CSA with respect to h. Let me simplify this before. 2 pi into under root of, let me take 4 as LCM, 4r square minus h square into h. Square root of 4 is 2, okay. Let us cancel this. This will I get pi h into under root 4r square minus h square. This is the CSA. Now let me differentiate it with respect to h. I will get it as pi into UV rule. H into 1 by 2 root 4r square minus h square into minus 2h plus under root 4r square minus h square into 1. Yes or no? Once again check here. Pi, I have taken it outside. H into this. H as it is, square root ka differentiation is 1 by 2 root x into this differentiation is minus 2h. Plus again I will keep it as it is, h ka differentiation is 1. Clear? Fine. So let me differentiate it and equate it to 0. Then I will get the value of h directly. Yes, let us equate it to 0. What do we get? This is a term. Therefore, 2 will get cancelled. Minus h square by under root 4r square minus h square plus under root 4r square minus h square is equal to 0. Let us put this here and let us send this term that side. I will get it as under root 4r square minus h square is equal to h square by under root 4r square minus h square. Cross multiply. Then 4r square minus h square is equal to h square. Why square root into square root will become a normal term. Then 4r square is equal to h square plus h square, that is 4r square is equal to 2h square, then h square is equal to 4r square by 2, 2 2's will get cancelled, h square equal to 2r square, then h is equal to square root of 2r square, finally h equal to root 2 into r. Clear? Then if you substitute that h here, obviously will get a maximum value. Clear? Or else after doing this again we have to substitute in that. Okay, if we substitute in this parameter, where is it? CSA. If even if you substitute h value here, then you will get the maximum value. Since we doesn't have any r value, we can't define it. Okay, is it clear? Once again let me tell you, it starts with the CSA of a right circular cylinder. We have given the relation of radius of cylinder, then we have substituted in the cylinder area, then differentiating it, equating it to 0 will directly get the height. Clear? Did you understand? Fine. What all we learned in this topic? We started with the basic of errors and approximation, then tangents and normals. Again in that we learned how do we find the slope of a tangent, then angle between two tangents, length of tangent, subtangent, normal. Yes. After that the rate of change, then these mean value theorems, Rolle's theorem, Lagrange's theorem, then increasing and decreasing. Finally we learned how do we find the maxima and minima of a function. Clear? Fine. By this we can end the chapter applications of derivatives, and hope everything is clear for you. This is the last chapter of your 1B. Yes? Fine. I think everything is okay for you. As of now we have discussed whole in the chapter of 1B. Yes? Fine. This is Sai Prasad, Alexan, Ahmedabad High School and the Junior College. Thank you.